I'll record on this computer and then I'll share it with you once I upload it. Okay. Right. So yeah, what I was talking about is that most of you are familiar with GIS, but I don't think that per se you understand what is GIS in terms of a technology and in terms of a subject. So because of that, when I try to approach you in a previous occasion, you think that it's just about technology and it's just about learning a software or something like that. But it is not like that, and I don't like to be in that position. So therefore, I wanted to elaborate a bit more about GIS and its ramifications of the current technologies. So let's move on. Let's see what this is about. And good evening to all of you. Let's talk about an engineering perspective to GIS. So in this presentation, I will be like segmenting my slide flow as data acquisition and storage, and what is GIS in the context of spatial data science. I think it's somewhat a new term that you are going to hear today. Maybe you have already heard about it. And GIS in the era of information science, and then the way forward. About the last part of this one, I'm kind of reluctant to talk in detail, but most of the time I will be setting my stage up on the first part of this one, and then I'll be explaining a bit more about technology. We'll move back and forth about what we can get more from this particular topic. Okay, so the first thing is data acquisition and storage. So let's move on with this one. Now, we are familiar with remote sensing to some extent, but we don't know what remote sensing is actually about. What is remote sensing's capacity? So we do remote sensing every day. Now, if you look at this one, you can see before knowing about the animal or the object in front of you, it's wrong that if I tell it's an animal. So you see an object and you start feeling about the object. You sense about the object. It's muddy, it's brown something, and smelly. It has a fairly large size compared to other things you see. So that's about the information. That's about the data that you acquire just by looking at it. You don't touch it. So the basic principle of remote sensing is that you don't go there and you don't physically interact with the object, physically in the sense of contact, but we do interact physically in terms of light. So that is the idea of remote sensing, that anything that you can acquire as an information from remotely observing, remotely locating yourself from the object, you can basically get that on as an information. So that is the idea behind remote sensing. Now, when you look at the definition of remote sensing, it's about acquisition of information about an object or phenomena without making physical contact with the object. And we have several application domains. Like engineering is where you are located at the moment, but the world is different. So we have geography, land surveying, hydrology, oceanography, and also areas where you kind of predominantly talk about nowadays about pandemic modeling, pandemic prevention, and policy decisions and things like that. So it's a vast area. So if you have the capacity to learn remote sensing and GIS, you have opened doors for large domains. The scope is really big. So that's what the first thing I want to tell you about. And moving on about remote sensing as a subject. So what we've learned first is about electromagnetism. So I think you are all familiar with these concepts. Like we have the sensors, our eyes, and we see that, and our cognitive capacity will process the information for us, and that is the visible spectrum. And beyond the visible spectrum, I am sure that you have worked with satellite remote sensing, where we talk about hyperspectral imaging, and also we talk about IR, and for some extent we talk about, I'm not sure whether you're talking about the radar remote sensing, but we do talk about radar remote sensing in some cases. And these things very simple. Like it's from electromagnetism, you acquire information, and those information differ based on the object that our electromagnetic radiation interact with. And I'm not going to talk about this in much detail because you are already familiar with the concepts of electromagnetism. Now, there are types of remote sensing. Like first thing is the passive sensing techniques, and then you have the active sensing techniques. So in the passive sensing, that is what we usually do when we observe an object. When we look at an object using our naked eye, we kind of sense the system passive in a way that we don't put energy to that object. So we can sense the system naturally with the naturally available illumination. That's why dark, when the situation is dark, we don't get the information from the object. So as long as the detectable energy is there, the system will work. So it's more like what our eye and our visionary capabilities are about. It's passive sensing. And active sensing is when you put an energy to some object and then you get the reflectance from that and analyze that reflective energy to come to some conclusion. So if the particular object has some chemical composition, then the energy will be absorbed and so on and so forth. So you can do your analysis. Maybe it can even be AAS, the atomic absorption spectroscopy. So it's in general, it's very simple to understand. You have the passive sensing systems and you have the active sensing systems. Now, why we talk about that is each object has their own different types of target interactions with the electromagnetic radiation. So it depends on the intensity of your energy. It depends on the direction and the wavelength, also the phase of the signal. And because of different types of signature patterns, the objects behave differently. And you can, like, even that's what we see as color. So beyond color, we can think of different signature patterns like IR. I'm sure that you are familiar with NDVI. So vegetation index and soil moisture, all these things are like signature patterns that depend on the object. Then, like now, this is where we come into GIS. Now we have information. That information can be analog information. It can be like noise from environment. It can be the vibrations. It can be anything that you can imagine. Specifically, if it is an electromagnetic related information, we convert that energy into digital information. So that is where your information storage comes. You inform your data and information, you acquire them from remote sensing means, and then you keep them as digital images. So all these, if you look at the digital images here, you can see that depending on the information that you acquired, your pixel values will change. I mean, that's very simple for you guys who you are familiar with subject, and also maybe some like first year, second year students are there. They also know about digital images anyway. So the pixel is there, is 255, 0 to 255 values, and you can store information based on that digitization. And that digitization actually creates some sort of a loss in the information. And there are algorithms to retrieve that loss, and also ways to actually come up with the information that we want rather than what we can get, because it's not easy to store large amount of data in a system. And you guys might be aware of this thing, because you need like terabyte or above data storage limits in order to at least capture a certain phenomena for a long period of time. So we are limited by the hardware, and we are limited by the software capabilities, and because of that, actually we tend to use what we can to the optimum ability. So therefore, we segment the images, and we can keep the images as separate information hubs. So when we want them, we can retrieve them. So that is about remote sensing, because that information and that idea about the subject is very important to carry on this discussion. That's why I kind of did the first part, so that everybody is on the same page when we talk about the rest. So let's move on with what we are going to talk about. Now, what is a GIS system? Now that the previous slides talk about the information as a whole, we had remote sensing data, how we acquire them, and what is GIS as a whole. We talk about it first. Now, GIS is what you call a geographic information system. So in a geographical information system, what you have, imagine that you are looking after some like, let's say herd. It can be a buffalo herd or something like that, and you have your own, let's say your house as a buffalo, and this is that guy, and then there is another guy from your neighbor. So I'm not saying that this happened in the past, but it can certainly happen in the future. So and also it's happening right now. So you geotag the the buffalo or the whatever the animal you want to geotag, then you put him there, and there is the other guy. Now these are for information, the coordinates and the location information we can acquire using the sensors. But once you acquire the sensors, sensory data, you need to store them in a place where you can do your analysis, or where you can do whatever you like, maybe keeping for the historical purposes. So a framework of gathering, managing, analyzing data, geographical data, is called GIS, a geographic information system. So like the most important thing you need to remember is that GIS is not a software dependent thing. Anybody can have a GIS. The reality is that people have very little capacity to keep GIS, geographic information system. Therefore, the other companies like software companies and maybe other entities where they specifically do these things, they come into picture. So because of that, you might see different types of software in the market, different types of people working on GIS, and they say that I am doing GIS, this guy is doing GIS. So most of you might have an idea about GIS, but think that GIS is all about software. GIS is not about software. GIS is about hardware and software both, and also it has a lot of auxiliary information required, auxiliary resources. So a geospatial data layer, it contains of a map, and it can be a 3D visualization. Also, it can be used to identify patterns, situations, relationships. So now, I'm sure that no, don't confuse my presentation with any lecture that you have had previously. Maybe they depend on different contexts and textbooks. But GIS for me and for the high-end experts is about acquiring data and keeping data for the analysis purposes, and also for how to say to have a much wider impact. It's not just doing things with the software. So because of that, that's why we say that GIS is about smart decisions. So a lot of you might have heard about data science at the moment, because I think there are a lot of courses in the internet and talk about that. Even some of my talks were about data science. And data science is about using data that's available at the moment, using the sensory data in order to come with smart decisions. Now, when you have data like that, they have a very specific nature, especially when you are talking about geographic information. You have location data. So it's not easy to process location data. That's I'll tell you why. Because if you think about even this scenario, where you have your buffalo or someone, let's say the guy here, then around him there is a spatial correlation. So in normal mathematics, like in the mathematics related to data science, what we do is we are trying to find out the correlation between data. And in GIS data specifically, we have higher autocorrelation around that object. Autocorrelation means I think maybe fourth year students, if they are joining this, they know that something called variograms are there. So variograms means that when the location, when you think about a point wise location, the more you go away from the location, the influence of that point becomes less. It's like gravity. You know that gravity depends on the inverse law. When you go away from that point, the influence of the object on something else gets reduced. So same thing happens with the spatial data, because if you look at this point here, because of this guy, there is a high concentration of blackness, or maybe let's say, let's talk about it in simple terms. You have a high concentration of a certain color at that point. That's because his or her presence is creating a correlation, or it's creating an anomaly on the image. So when we are dealing with geographic information, we have this high autocorrelation with respect to the location, and also with respect to the phenomena that we work with. So this getting into smart decisions using GIS is not really a simple task. It is quite challenging. Now, because of that, we move from simple data science to spatial data science. So as I told you, the first part of data science, or the nature of data science, is about database, big data systems, statistics, machine learning, data mining, data visualization, on whatnot. So all these things are like modern applications. We'll come to that in a while. And when you talk about spatial data science, we talk about extracting knowledge and insight, as well as causal relationships of spatial phenomena. So this causal relationship, I'll come to that in a while. This is the most important thing about spatial data science, that we not only take the data dependent information, we also try to take the causal dependent information as well. Causal means, like, if you do an experiment in the laboratory, let's say you put X and you put Y and mix them together, and you expect some kind of a outcome. So that is kind of an experiment. Then you change the concentration of X and Y, and you try to see what will happen in the future. So that is the causal relationship. Causal relationships differs from typical data science, the frequentist approach, because it talks much about Bayesian data statistics. Bayesian means your previous experience depends on your future outcomes. So likewise, spatial data science is a highly Bayesian approach, because your location and also your history will cause your future actions. So if you think about a road, you understand that the vehicle or the car is not going to go sideways. It will keep on moving on the road. So that is Bayesian, because we know that because there is a road, the vehicle is moving on the road itself. So if it is moving away from that, so that means there is an issue, right? Like that, we kind of have information from data, the spatial data. Because of this thing, oh, I'm sorry, there's something here. I just, sorry. So because of this, now spatial data, spatial science, and data science combine together to form spatial data science. Now, this is the current status of GIS. We are not talking about just a software, just map making, just making those fancy things with a node arrow and then grid. Those are basics. Like when you think about arithmetic operations in mathematics, that is kind of the thing you learn in grade 2 or 3. But now we are talking about higher level mathematics. So like not mathematics, but I'm talking about high level GIS. So we are talking about spatial data science, and we are now giving that a name SDS. So when you think about SDS problems, they differ from, it can vary from one domain to the other, but still the main concern or the scope lies in spatial data. So the information can be about urban traffic, can be healthcare. Right now we are facing some serious damages to our healthcare systems, and politics. Of course, you will be surprised to hear that some applications are really focusing on who's going to win the election, and there is segment marketing strategies. So that is a different scenario, but GIS is the main cause. I'm just want to elaborate on that, because that is kind of the area that you have to focus, because you guys are much familiar with analysis, and I think that is the way, if someone is interested in mathematics or statistics, that is a very good way to move forward. And you have public safety, hydrology, disaster vulnerability. Now this part, we always talk about this in GIS, and we basically we talk about vibrations, or we talk about landslide hazards. Well, that's kind of the history. Now we are not talking about them as a map itself, because GIS has moved from SDS to currently we are actually thinking about streamlining data with big data. So I'll come to that in a few moments. So you know that there are applications. Now, if you think about an example, let's think about how to find a strategic location for a mineral processing plant in a suburban area. Now, what are the concerns that you have already here? First thing is it should be a mineral processing plant. So definitely there will be supply from outside, from the mining pit or somewhere that the minerals are processed, and then or maybe secondary, primary crushing, and then tertiary crushing, and then you come back to the mineral processing plant, and then you have suburban area. That is a very important topic here, because suburban area means there is some human activity as well, and there is water, there is environment. So it's not that easy when you think about it in terms of the spatial correlations. Now, when we approach that, you realize that why is this line there? Oh, I think because of the Zoom, I have drawn something. Okay, I'm sorry. When you think about the problem, you have a causality approach, cause and then effect cause relationship. And also at the same time, you have data mining problem. The causality approach means that actually you need to find out whether your vibration is causing problems to the nearby places, and also you need to find out the certain science behind it, the physics behind the problem, if the area is having some slope stability issue or the water problems. Now, these are causality dependent problems. And then you have data mining problems, like how many people are going to live there, and is it open throughout the year, and what are the factors that you need to think about when you try to move forward from their geopolitical problems. When the variability becomes high and high, and also the number of factors that are causing the variables to change is increasing, the number of independent variables are increasing, then you have to go for high-end data mining problems like artificial neural networks or machine learning in a broadly sense. So that is how actually your data becomes information for someone else. Now, GIS is part of that. SDS is the main cause of why you get that particular marketing ad. That's why you get that particular ad about the class that you were thinking about. And that is why you get, say, if you are searching for mobile phones or searching for a vehicle on a given area, then you keep on getting the ads for that area. It's not simply machine learning. It is also about SDS as well. So I'm not saying that I'm using it, but the specific marketing strategies and specific focus locations are derived from SDS. So that again about GIS. And let's focus on something that is crucial. Now, I have to tell you this, that I work for a certain company, certain tech company. I avoid using the name because this is for entirely educational purposes. And I don't like to have that misinformation about my involvements. So all of their work, like it's a single entity as me, I cannot do all these applications by myself. So most of the successful stories that I am going to present like for another 10 slides or something, they are from other people, like from different individuals and different organizational strategies and applications. So they are not my videos, but I'm going to share it with you so that you get a very good idea about the applications of GIS at the moment. Now, take a look at this. Now this one is about dynamic visualization of geographic data. Now, you guys are familiar with data and positions. If you want more, insight about these things, I suggest you to watch a TV serial called Numbers. It's written as Numbers, NUM3. NUMB3 RS. 3 means the number 3. So there they talk about the spatial differences, how spatial correlations affect information, and how to use the information, spatial information, for your detective purposes. That is a crime-based TV serial, but I suggest you to watch that. Now here you can see, if they are just in a tabular form, you don't see how they behave in the real world. The locations, how they come to this point, what is the criticality of that point? Why do you need to select a certain point when you want, say, a strategically important topic? Then that is how you want this dynamic visualization of geographic data. And when you think about big data structures like Facebook, we are interacting with each other. You see that there are mutual friends and people who we know, and depending on the location, you get very good suggestions. That happens when you have this type of spatial organization, like spatially visualizing the geographic data. You can come up with very nice information about which point is location-wise important. And of course, this is traffic analysis, where you have the traffic building up and which area is more important to focus on. And this is similar to this one. It's about aviation and transportation. So you might think that it is only transportation. It's not. It's like even if you think about pandemic situations, this is about how people move. So you take the information, and it is GIS. From once you take the data, the visualization is all about GIS. Now the next one I'm going to show you will give you a very good idea about the capacity of GIS at the moment. Now, this advanced visualization of GIS technologies or geographical informations will give you a very good idea about like what to do next. So as I told you, GIS is a highly Bayesian statistical information science. So you have always the causality. Why this particular hotel is producing more revenue compared to the others? Why it is difficult for you to go to a certain school from your location, and why someone else might be earning better than you? It's all about organizing the data spatially. So like this video, like somewhere at the bottom, what you see is they are, if your town has some vulnerability to face aeroplanes. So if you're, let's say you are located near Katunayak area or somewhere near the international airport, then these high-rise buildings will have an impact on the landings of the aeroplane. So the properties, the value of the properties will change. And also if you are thinking about the hotel industry, based on the view, if you familiar with what we have at the goal face area, you can see that part of the hotels are facing the beach and the other parts are not facing the beach. So depending on the requirement of the guests, the price will change. So this becomes a critical decision. So if someone is just thinking about that as a single entity, then yes, you can work on that for years and then come up with a decision. But then you lost the economic viability of that decision. So that's why you have to handle big data, and you have to use big data visualization to high extent in order to come up with such decisions. So you can see some of these places, and also these are for some public safety measures. And the way data visualization will show you the clustering of data and things like that. So in order to do these things, first thing, you need to know that there exists such science and technology. Second thing is that you need to have some hands-on experience with them. So the other part, this one, let me show you if it is working. Yeah. So this is for a natural resource. I'm not sure whether you can read our natural language. This is not English. So what you can see is how resource management was done in a particular country, and how that information is used to predict the future revenues, especially for the mining industry. When you talk about the resource management, this is very important. And this one is about planning the aviation, like Los Angeles. From Los Angeles to, you have Tokyo here, and then you have you have Tokyo, and then you have the Heathrow Airport. You can see which extent and what are the most critical airports that if you are booking something, and especially Booking.com and other commercial applications, they rely heavily on this geographical information data, and also future, because after the pandemic, whether you are going to buy a certain hotel on a certain port, certain country, and where you're going to travel, and what is your frequent flyer, all these things matters, and they are in SDS, spatial data science, right? So this one, yeah, this one. This one is about smart city applications. Smart city, I don't think, since I haven't brought that topic up a bit, I need to explain it about, like smart city is like a living, breathing city. It requires information. It knows exactly what are the high traffic areas, where the resource should be managed, where you need to put your last bit if there is a problem, let's say an earthquake, a bomb attack, something like that, where you should locate your people. Everything matters, and smart city is something that understands all these things as information. So in smart city applications, we use GIS a lot. And this is about communication applications. It's also about your mobile applications, where you where the traffic density is highest. And I'm sorry. Now this one is somewhat classified information. This one was used in Mauritius somewhere, I think like 2 years ago, but now they are moving with the system. Now here you can decide which locations are most important for your next move as public safety officers or law enforcement. You can decide where your most critical location is. So that is where you use GIS and big data together. So you have to know the past records of that area, whether it's a crime, high crime rate is there, or whether number of females is high or not, and whether the incidents about let's say child abuse or rapes are high. So in those cases, you can decide the overlay that you're going to put on the data, and from there you can get the locations like this. And from there onwards, you can decide where your strategic moves should be. Like for instance, I'm just talking about how this application works. Let's say that you are the Demeter police, and you can access the Borel area. Then if there is a crime happening somewhere in let's say Rajagiri or somewhere, and then if you know that there is a chance that particular person is going to elope or escape from Borel area. Of course, this is from experience, but when the system is giving you the assistance in getting the decision correct, then of course that becomes a very high success rate in capturing. So this is used in public safety a lot. And I talked about the company applications and individual applications, and also the high-end tech that I am working on. So from there onwards, if you can guess what I'm going to talk about, the way forward, it will be mostly about you, like where you should invest your future if you are interested in RS and GIS. Like what are the areas that are prominently developing at the moment? Since I am familiar with the current technologies, I can tell you that these are the kind of the future of GIS. So if you look at closely, you can see that the current technologies are not just maps. They are not just map making, and they differ from simple map making to very high-end products. So you have to understand, first you should become good engineers. Second, you should harness your analytical skills. And third, you should invest your time on learning new technologies, because otherwise the trend is so fast and you will be lagging behind, and you will be thinking that, oh, I could have done this earlier. So both causality approaches and data mining approaches are getting getting the bus. People are getting really enthusiastic about them. And then about spatial information, if you are trying to learn new technologies, best is to learn about the spatial related information. And of course, people think that GIS is an IT job. GIS is about DBM, database management, or these computer science things. No, because there is a part of GIS that requires IT, hardware and software both. But the majority of GIS decisions come from analysis. That is about 60% of GIS entirely depends on your application domain, the place and application that you wish to apply GIS. So be good experts in what you want to be, and then learn the GIS to apply on those areas. So then only you can expand as a GIS expert while providing the necessary service for your application domain. Cloud-based solutions, they are mostly for IT personnel, because they are the ones who are developing these cloud-based applications. And then real-time data visualization, that's also part of the IT work, but getting information and getting into the decisions from there is about it's the job of the analysis, right? So I jot down 6 key technologies at the moment. One thing is drone technologies in GIS. I think some of your colleagues and some of your friends have already done some work in drone technologies. So this includes entire spectrum of simple drones to other data acquisition means, like some vehicle-based images and all, which you have seen Google how they do their maps. And then big data GIS, augmented reality, and building information model GIS, and 3D GIS. Also artificial intelligence in GIS. So in this presentation, I will talk about drone technologies and artificial intelligence in GIS because that artificial intelligence depend on big data as well. But I will show you a video that's from YouTube directly. I'll just show you that what this augmented reality GIS is. It is not easy to show, and it's not fun to show it in a presentation like this. Let me first show you about what is oblique photogrammetry. So oblique photography is just the photo that you take in an oblique angle. So you know that general satellite data comes from directly lying above the point of interest, area of interest, AOI. So the image comes like directly as a perpendicular sense. But oblique photogrammetry is when you get the image in a oblique manner, like it has an angle. So because of that, you get the visualization a bit distorted. So because of that, you have to apply high-end image processing techniques to rectify that and put that into the perspective of the coordinate system. So oblique photogrammetry is very important because it has a lot of applications where there is a scarcity of satellite information. Because as you know, satellite data having a coarse resolution. They don't. They have like 25 meter by 25 meter grids or something like that. So when you are dealing with a city like this, you don't know what is happening somewhere here. So because of that, you can take a drone, 20 minutes flight, and you can get a very nice view of that area. Then you develop the mosaic. From there, you develop your oblique photogrammetric things. You can see some of the technologies they use right now. This is a 4D camera. It's more like it can create the mosaic of the image, and yeah, you can see it can take different angles and then combine them together to create that 3D nature of the photo, and then they overlay together to get the if you remember your photogrammetry lessons, we can overlay two differently angled photos and then get the 3D elevation. So we do that in oblique photography, and you can strategically locate the points and then take the images as you like. So that is some improvements with the drone technology, because you can locate your drone to the places you like. And this is about the full process. Maybe you are familiar with point cloud technology. Point cloud is when you get information like this in 3D, and then we segment it into different points, XYZ points. So that is a point cloud. It's just a cluster of points. And then TIN, of course, I think you know about TIN, terrain models, and then you convert into digital model, and then you get 3D model. Now, the good thing about this technology is that it helps our it improves our understanding about the real world as is, because some of these buildings, if you think about this building top and this part of the building, the bottom part of the building, they are located in a significant height. But if you look at the satellite image, you don't see that height. And that becomes a problem when you are making decisions for that specific location. And therefore, this oblique photogrammetry is getting really high-end technology for those type of applications, specifically when you are thinking about small-scale applications or places where you don't get enough satellite information. Right, now this one, the Gartner Hype Cycle for AI, is published research. It's about what will be the future of AI in terms of GIS. Now you can see that the current GIS technologies are somewhere here, the deep learning, machine learning, natural language processing, and speech recognition, and all this area. But the peak comes at the point of inflated expectations. This is where people thought that AI would be able to behave like humans, and that was far from what we achieved at the moment. Like 1980s, they thought that computers would behave like humans, they interact with us, but that never happened. However, from the declining trends of expectations, we have now reached a point where artificial intelligence has been used heavily in GIS related research. So if someone is interested about future of GIS and as a technology itself, so data science and GIS, spatial data science, is the way to think about it. And of course, it's like not GIS alone. So there are other things that you need to learn. Therefore, you need to really be experts of what you learn right now, and then think how to apply GIS for your applications. Now, that is part of me for this presentation, and thank you for your attention.